Alright, hello again everybody. Now we're going to do lesson 3.2, synthetic division, with the remainder theorem and potential zeros of polynomial functions. So it says division algorithm, let f of x and g of x be polynomials with g of x of lesser degree, so that's the smaller number, than f of x and g of x of degree of one more. There exists a unique polynomial q of x and r of x such that it's g of x times q of x plus r of x. And remember, q stands for quotient and r stands for remainder. So it says to avoid errors, use blank as the coefficient of any missing terms, including a missing constant when setting up the bit, so use 0. So you have to make sure that the exponents are in descending order, not missing any. So like this is 3, 2, 1, none, so I didn't miss any. Alright, so to set up these problems, and most of you have seen synthetic division before, if it starts out as a fraction, we're going to take the denominator, set it equal to 0, and solve for x. So whatever we solve for goes on the outside of the box. And then we put the leading coefficient, so I'm going to put a 4, a negative 15, a positive 11, and a negative 10 under my division box. So I'm going to drop the 4. So whatever the first number is, you just bring it down. Then I'm going to multiply. 3 times 4 is 12. Then I'm going to add. Negative 15 plus 12 is negative 3. Then I'm going to multiply. 3 times negative 3 is negative 9. Add 11 plus negative 9 is 2. 3 times 2 is 6. Then I add again and I get negative 4. Whatever is in this last box is always your remainder. Now to write my answer for this problem, so this was cubed, so this is squared, so it's 4x squared minus 3x plus 2 plus a negative 4 over whatever you divide it by, x minus 3 in this case. So because we divided by an x, that's why this is x squared, then just x, then none, because you write them in descending order. Okay, on to the next one, number 1. And it's in a fraction form. First you have to solve for x. Problem. So this one's a little bit different because it says special case of the division theorem. For any polynomial f of x and any complex number k, there exists a unique polynomial q of x and number r such that the following holds. So this is the divisor, the quotient, plus the remainder. So if the remainder f of x is divided by x minus k, then the remainder is equal to f of k. Okay, so the first one, so it says, applying the remainder theorem, let f of x equal negative 3x to the fourth plus 15x cubed minus 50x plus 25, and use the remainder theorem to find f of 4. So whatever number is here goes on the outside of my division box. And then if you look, it's to the fourth power, third power, to the first power, so we skip the second power. So it's going to be negative 3 plus 15, 0, negative 50, and 25. So we do the same thing. we drop the negative 3, we multiply, we get negative 12, we add, we get 3, we multiply, we get 12, we add, we get 12, 4 times 12 is 48, we add negative 50 plus 48 is negative 2, we multiply, get negative 8, and then add. So what this tells me is that the point 4, 17 is on the graph somewhere. Okay, so potential zeros. A zero of a polynomial function f of x is a number k such that f of k equals 0. Real number zeros are the x values and x-intercepts of the graph of the function. A zero of f of x is a root or solution of the equation f of x equals 0. Alright. Okay, so this last place says to decide whether the given number k is a zero of f of x. So it is a 0 if the remainder is 0. So like the first one, so k equals 2, so 2 goes on the outside, and I have 2, negative 3, negative 18. So I had 3, 2, none, 18. So we need to have a 0 where x to the first power should be. So I do the same thing. I drop the 2. 2 times 2 is 4. I add, I get 1. I multiply, I add. I multiply, I get negative 10. So the answer is no. Okay, and then the next one. K equals negative 3, so negative 3 goes on the outside. I have 4, 3, 2, 1, none, so I don't have to add a 0. So 1, negative 4, negative 14, 36, 45. I drop the 1. I multiply, I add. I multiply, I add. I multiply, I add, I multiply. The remainder is 0. So yes, negative 3 is a 0 of this function. Okay, we're not doing this one here because it has an imaginary number. Okay, so when I tell you that k equals, you just put k on the outside of the box. If it's like the exact, I hope everybody's staying safe and washing their hands. I'll talk to you soon. Remember, if you need anything, just email me.